Okay, should we start?
Yeah, but you can start.
All right. So last time we wanted to write a program that checks if number is even or odd. So what you can do is, for example, a equals write whatever number you want and write if a. And so how do you know if it's divisible by two? You can modulus two, right? A modulus two. And if the remainder, so a modulus 2 finds the remainder, and if the remainder equals to 0, that means this is even number. So we can print out, say, even number. Or now we can add else, right? So if a remainder 2 doesn't equal to uh, 0, so basically we can say print odd number. So this solution is not perfect, but it will work for all integers, right? You can write 15 or minus 2, let's say, to also work. But if you have like a floating point number, etc., then uh, it will, I guess, say odd number, which is not true, right? Right. So maybe you can then do else if. So this is the middle statement. So sometimes you want to stack if conditions. In Python, we can do elif, and then elif is a conditional, so you require another condition after this, and then you print odd number and else. So now we have three branches in our code. We have if it's divided by 2 equals to 0, the remainder is 0, then it's even. If it's 1, then it's odd, and if it's like a 2.5 decimal number, floating point number, then it's gonna say neither odd or even. Okay, so um, additionally, you can combine print statements. So for example, you can combine A and say space is even number, right? Then we're gonna plug in A here, and then we're gonna add this statement after. And there's this space here is to make sure there's a space between the 2.5 and the is. If you don't have it, you will have directly the answer. So let's see. Let me show you if you have like two. Actually, it is not like this. Okay, so CC it's like this. So Python seems to introduce the space regardless. So then there's no problem with this space. Okay, so make it like this. So 2.5 is neither odd or even. So that will be a solution for this problem. Okay, so today we wanna go into loops, right? So what, for example, imagine you wanna print out hello world 100 times. Then you wouldn't want to write print and then like copy paste this over and over. So for this kind of purpose, a lot of things, especially in math and computational stuff, we have tons of uh, lot of things we calculate. Otherwise, we can probably calculate by hand. So computer is there to help you calculate millions of numbers, billions of numbers in one go. So how can we do that? We have for loop. and while loop. So we start with the while loop, which is a bit more fundamental uh, in Python, because Python's for loop is slightly different than other programming language like C++, etc. So mm, let me show you how, let me just show you with an example. How can we print hello world 100 times? So while loop requires a condition afterwards, so some kind of condition. And then if this condition is true, it will do whatever is within this block, just like a if. So we have a condition, but the thing is, it will run this non-stop. So basically, you go to a while and then you print this, and then you go back to the condition, check again, and then keep on doing it. So if you have such a thing, you have, for example, this while true, then you go there, check, yeah, it's true. So you do the hello world, and then you go back, still true, do the hello world. This will continue for infinitely long. So it'll cause some kind of crash. But to avoid this, right? Also, we want to basically have a condition to exit out of the while, right? So what we can do is, for example, let's say we want to print out hello world 10 times. Then we can initialize a variable called I, right? This is a very commonly used letter. I is usually standing for index, right? So in coding also, everything starts from 0. So index is 0, while index is smaller than 10, we print hello world. Now this will still uh, cause a crash or like run for infinitely long because I is 0. And this is true. 0 is smaller than 10, true. So we print and go back and check again. So how do we avoid printing more than 10 times is actually we increment the I. So in Python, there is no plus plus like C++. Basically, what we do is I equals I plus 1. Okay. So what we're going to do is we have 0, and we go into the while loop. 0 is smaller than 10. That's correct. Print hello world once. I is equal to, now we assign. So this equal is not a mathematical equal sign, it's a sign, right? So what this means is now we put our 0 here and then we add the 1. And then now this is equal to 1 assigned to the I. So I becomes 1. Now I is equal to 1. 1 is smaller than 10. You go print hello world. And then now is this I is 1. So 1 plus 1 equals 2. You put into this I. So this is why you have to understand that programming is equal is an assignment, right? So we call this I equals I plus 1. In general, we just increment the index, right? So everything after this symbol is a comment, only useful for the programmer to understand, as I mentioned before. So this will be the most basic while loop structure. You will have some kind of index or something that will change within the uh, block. Otherwise, it will basically go to infinity, right? You'll do the thing infinitely many times. So if you run this code, we are printing hello world how many times? Should be 10 times. Because I will basically go from 0 all the way to 9. And then when it becomes equal to 10 here, when you come here, 10 is smaller than 10 is false. Then we get out of the while loop. Okay. So using this while we can, for example, print out the index instead of the hello world, right? So instead of hello world, we print out I. Then we're printing all the indices from 0 all the way to 9. Loop is going. All right, so that is while loop. Quite useful if you want to do many things. Another example would be let's write a function that, well, let's just do some factorial, okay? So let's say we want to find out factorial of some number. Let's say factorial of small n. So n equals to 10. How do you do the factorial? Factorial is basically, right, we multiply 1 times 2 times 3 times 4 times etc. So what we can initialize the factorial, right? So let's initialize this variable. Initialize, if you initialize with 0, everything you multiply afterward will be 0. So we're actually going to initialize it with the 1, and then we're going to multiply. So while I still have the I actually. I equals to 1. No, actually, 0. 1, 1, 2, 3. Let's do it 1. Okay, so while I is smaller than and equal to n, because we have to multiply all the way until n. So this is a smaller and equal symbol. Make sure this is not equal and smaller, because that's wrong. Like, equal and smaller. This sign will not work because the code will read equal as an assignment first, and then it will not work. So while I is smaller than or equal to n, what we can do is we can multiply the factorial by the I, right? So let's think about what's going to happen. Factorial is initialized with 1, and then we first multiply by 1. I equals to 1, and I hasn't changed. 1 is smaller than 10. Factorial equals factorial. So factorial equals 1 times I. I is equal to 1 here. And then I becomes equal to 2 in the next round. And then 2 is smaller than 10, etc. all the way. And we can print this out. There's no printing, so we have to print it at the end. So this print is outside the while block because I don't want to print out all the steps in the middle. So we can say n, and then comma, factorial is equal to fact. Let's check the code. So 10 factorial is, okay. So maybe I could just change to this symbol. So 10 factorial equals, okay, actually, it's not confused. So 10 factorial equals this number. Maybe it's correct, maybe not. Let's check some small number. We know something like 5 should be 120. Yeah, so 5 factorial equals to 120. And we can now go all the way until, I don't know, maybe 50, right? So the code is able to find us the factorial of 50, which is some really large number. Okay, so that is how you use while loop, which is quite useful for finding stuff like factorial. Okay, but normally this is just an exercise. But later when you learn this package called NumPy, we will not write our own factorial code because someone else has already written this and we can use this kind of code. But I'll show you that later. Okay, so that's while loop. Next one is a bit more commonly used. So while is usually used when you don't know when to end. But I showed while first because while has similar structure as if. But for in a Python is different than other programming languages. So for loop. Mm. So let's describe for loop. For the most common way of writing it is for I in range. So let's write the exact same code as before, that we're doing factorial here. So for I in range n, what can we do? Let's initialize the factorial beforehand. Fact equals 1, and then fact equals fact multiplied by I. Turn, no, return, print, fact. Right? So it looks quite similar to while, but there is this keyword in, and there's like this range, etc. This is the most common structure of for loop that you're going to use in Python. But let's go deeper into what the range does. A range is a built-in Python function that gives you an array. If you remember, we last time introduced some arrays. Am I missing something? Ah, yes, I'm missing something. Yeah. So I'll explain what range does first. So range is a function that returns the list of numbers from 0 to the given number. So let's say range of 5. Then it will basically go from 0 to 5. Okay. So when you write for I in range 5, then we basically go through 0, 1, 2, 3, 4, 5. No, 5 is not included. So until that number. That's why I just add n plus 1 here to make my factorial work. Okay, so one more thing. If you have a range, so range of 5 would go over 0 to 4 inclusive. Okay. Let's demonstrate that for I in range 5, print I. So we have 0 to 4. Now, range, so here it takes only one argument, the range function. But if you give two arguments, the first can tell the starting number, second can tell the ending number. Okay. So if you have for range 1 to 5, for I in range 1 to 5, print I, then it will print from 1 to 4. So always this first start is inclusive, but end is not inclusive. So start is inclusive, but end is not inclusive. So remember that. Now, one more range. If you have three, if you give three inputs, it will do something in bit different. So for I in range, let's say 1 to 5, but third argument is 2. So what the third argument does is, if you give three arguments, it will say, first argument is going to be start, second argument is going to be end, third is going to be the step size. So if you print now I, we basically go from 1 to 5 with the step of 2. So basically 1 and 3 will be shown. 5 is not inclusive, so it's not going to be there. But if we, let's say, make it 6, Then we have 1, 3, and 5. So that is a for loop. You can basically index. We're gonna go through this code where the index is gonna vary from whatever range you set, basically. Okay, so let's go back and show the implementation of factorial. How did we implement the factorial? Is if factorial, we initialize the fact variable as 1 because we will multiply stuff on top of this. And I is now starting, I is going to be 1, and is going to be n plus 1. Why plus 1? Is because stop is not inclusive, so we want to add 1. So if you go to 100, instead we go to 101, and then the last one is not counted. That's why I have this plus 1 to deal with that. So now the factorial. Let's demonstrate with a different small n. Let's say n equals 2, 5, and we have 120 as the factorial. And that's the for loop. Now, next topic is gonna be nested loop. Okay, so usually when you use a nested loop, okay, this is just usually, but you can do whatever you want. A lot of the times in math computations, we will use for a bit more often. While is, so what is the difference between for and while, right? For is usually used for when you know the amount of iterations you want to work on something, or when you know the I. So for I equals to 1 to 6, you go by 2 steps. But sometimes there are cases where you don't know how many times you have to run something to until you stop. For example, when you uh, solve some equations numerically, we don't know exactly when to stop. So we don't know how many iterations it will take to converge onto some number. Okay, so then we use while. Okay, I have a funny idea. Let's demonstrate that why we need while sometimes. So, um, you know the mathematical sum from 1 plus half plus 0 point, like 1 over 4 plus 1 over 8, etc. And this sum equals to 2, as you know, from some limit. Okay, so for example, we can do stuff like a equals to 1 and while, okay, sum, let's define the word sum. Sum equals to 0. So we initialize the sum as 0 because we're going to add numbers into that 0. So while sum is smaller than 2 minus, let's say, some tiny error, so that we will at least approach this tool, right? If you know the epsilon delta notation of it limits, this is kind of how it works, right? So basically what you can do is sum equals sum plus a, okay? But what we're gonna do is we're gonna change our a into a divided by 2. So a is gonna start at 1, and then we're gonna add 1, then change a to half of it, go back, and then when sum is smaller than Or we can say, let's, instead of this, we can also say, we will add while a is larger than some number. So while a is large enough, we will keep on adding this. So let's check what our answer will be. So let's print out what the sum would be. And you can see the sum is 1.99999, blah, blah, blah. Basically, is equal to 2. So this could be one way. Basically, here it's like kind of like a small error term. So we're basically just making sure uh, the error is small enough by doing this. Okay. So while is used when you don't know how many iteration it will take to converge or how many iteration it will take for something to happen. But for is used when you know the amount of iterations. That is the biggest difference between those two. Next thing I want to talk about is nested loop. So a nested loop is when you have loop inside a loop. So a lot of times you want to like have the two-dimensional problem. You want to go over the x-axis and then the y-axis. But for every x-axis, we go every y-axis. So normally it could be written as like this for I in range of, let's say 5. And then within it, we'll write for j in range of 5. So I and j and k are commonly used variable names. But you can use whatever you want, but it's very common to use I and j. So let's say print I and j. Does it work? Yeah. So what are we doing here is I goes from 0 to 4. J also goes from 0 to 4. But for every time I equals to 0, J is going from 0 to 4. And then when I equals to 1, J is also going from 0 to 4, etc. So we, in total, think about how many print statement we're going to have. So we're going to have 5 times 5, 25 different statements. So these nested loop kind of stuff will be useful when you work on two-dimensional problems. And when you go to NumPy, it will make more sense how useful this is. Uh, Also, we can do very cool stuff. I think in Python print without. Okay, so in Python, every time you print something, you are creating a new line. So going from 0, 0 to 0, 1. But let's say we don't want to do that. So we want to print I and j, right? But we specify this end argument that specifies between two print statements, we are not gonna go to a new line, but rather it will just be a space in between two print. So let's see what happens. Like this. So everything is now just uh, written in this order, but this is not easy to see. So I'm going to add another statement. So basically every row, we're going to add a empty line. So now what we have is a nested loop where I goes from 0 to 4, j goes from 0 to 4, and every time we are printing the I and j, and then we go in this way. Okay. Um, just for simplicity, let's only print out the j, and it will look makes a bit more sense probably. So what we're doing here is the outer index tells you to which row you are on, but the column number is basically j. So we're printing for every row, we're gonna go over this for loop. And this for loop is gonna print out the j like 0, 1, 2, 3, 4. And at the end of this printing, there is always a space. So 0, space 1, space 2, space 4. There's a space, actually. You can't see it, but you can select it. You can see that. And this print is now gonna make it go to there. Why did I add this print? Is because whenever you print in Python print default always starts a new line, right? So we start a new line, and then we do the same thing again. How many times we do? We do it 5 times. If you change, okay, 5 may be a bit confusing. Let's change to 8 and 3, and then we'll see. So the outside loop is 3 times, but inside we go over to 8 different things. So, and you can do some cool stuff, like if you play with it, for example, instead of going to 8, you can go to I. Now think about what this could give. For example, if I, what would this give? Okay. So it would actually give something like this. Okay, but that's another one, so it's better. Okay, so what this will do is basically we will go over from 0 to 1 and then print out 0, etc. So this way you can print out some kind of pyramid, right? If you change this into 6, now you have a pyramid that goes from 0 to 5. So this outer gives you the number of rows, and then this inner j would give you the columns, right? So the columns, when I equals to 0, there's only one column because 0 plus 1 equals 1 column. Now, when I will increase in this iteration, next time when this goes back, I will become 2, and then now you have 2 columns in that second row, etc. We can even play with it. We can make the pyramid fatter. So basically now in the range you can plug in like what I you want, etc. So it's very flexible. Whatever you want, you can do. So uh, yeah, that is basic for loops. So we are still working on all the basics of the coding. We are not yet working on specific math examples yet, but this is very important coding stuff to learn. Okay, next, I think let's do functions today. So, right? So what is a function? Function in Python is similar to function in mathematics, but it's also different. Okay. So a function in math has an input and an output, and it does something, right? But in Python or in any programming language, it doesn't even have to have an input or an output. But let's define some math function, okay? So in Python, we use the keyword def. It signifies what the function basically it's a function. So let's say define f1 and we give bracket and then say this is the variable we're gonna give. Doesn't have to be x, but let's use x. So, and within a function, we say return. So this is basically a value. So in other words, we are trying to write something like y equals f1 x, and the y is the return value basically, right? Okay, so let's do something. Let's say we define a function that returns square of this variable. So whatever you give into this function, we will square this thing. Okay, let's use this function. To use this function, we call it. So there's no def anymore because we're just calling the function. And we have to take the value to some kind of variable, y, let's say y. Y equals f1 of 6. Let's print out y. And we get 36. So a function in Python can be used exactly like a math function. That's one way. But also you can write some um, functions that don't have return value. It just does something. So let me show you some function called hello world. Okay. Now, function will be defined always with a bracket, but this time there is no variable. We don't need a variable. We can just define like this. And this function just prints out hello world. So right now it will seem like, what is this gonna do even? It's kind of useless function because you can just print hello world, but this is one example of showing that you don't need to have a input and an output. Okay, so we can call the function now. And since it doesn't have an output, we don't even have to have a return variable to pick it up. Just do the function. So we just run the function, go hello world runs. So to be honest, we could have done this same thing with the y. You could have just run f1 6. Okay. This is very special to the Jupyter Notebook thing. With Jupyter Notebook, whenever you write something, it will print out. But normally in just if you just use Python without Jupyter Notebook, it will not even print anything. So, but now we pick up the return value and then we print out that value. So that's the more normal way of doing the thing. Here we have define hello world, print hello world, hello world. So why do you need a function? Because you may use something over and over. You may do something over and over, and it's just nice to define a function for it. And especially in math stuff, it would be nice to define a function. Okay, so that is function, super general concept. Let's combine the things we have learned today. For example, let's print out squares of, let's say 1 to 10. So for I in the range 1 to 11, print. Okay, you can kind of stack stuff in Python, right? You can say print and then say f1 of I. So what is going to happen is I will go from 1 to 10 inclusive, 11 not inclusive, and print out the value of the function f1 y. So we go from 1, 4, 9, 16, blah, blah, blah. So that is how you combine for loop and the function. And you can also do this with while. You can combine for and if. You can do whatever. This is very flexible, right? So those are quite important basic stuff you need to learn. And basically, if you know all these basically can give you 90% of what you want. So everything I taught you up till now is basically like 90% of the most commonly occurring stuff that you will need to use. So basically the most fundamental stuff you use. Everything else you can just Google, right? But next time we will go over NumPy and Matplotlib, and that will be super useful for math people. Okay, so now as homework, I want you to try to print something like this, okay? 0, 1, 2, 3, 4, 5. And then 0, 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 0, 1, 0. So I want you to figure out how to print a pyramid, like reverse pyramid like this. That's one thing. Secondly, yeah, okay. Several things you can do. Figure out, write a function that sums all the way from 0 to n. So a user will define n, or you can just define it yourself, like n equals to 100. And what we want to write down is a function that's called a sum, something like this. And when you give n, it will print out sum from 1 to 2, 3, 4, 5, etc. So here you can use either the summation rule or you can use the for loop to sum. I suggest using the for loop to sum, just because you learn how a bit more about the coding. But of course, that is a bit more inefficient compared to just using the rule to some arithmetic progress. But yeah, so write down a function called sum_n that prints out whatever to sum from 1 to that n number, inclusive, right? So if you do sum of 100, it should give you like 50/50, I think, something like this. All right. So that's about it for today.
Yeah, but thank you so much for your time and for the today lecture. Uh,
Hi.
Hello, can you hear me? Hello.
Hi, what's up?
Yeah. All good, all good. A little bit busy today, but it's okay. Thank you so much for your time and बाकी सब आपका भी शुक्रिया। अच्छा, लोग पूछ रहे थे कि हमें पिछले लेक्चर्स का नहीं पता, तो उसकी रिकॉर्डिंग हम अपलोड कर देते होते हैं। आप मैथमेटिक्स मीडिया के यूट्यूब चैनल पर जाएं तो वहां से आप रिकॉर्डिंग देख सकते हैं, पिछले लेक्चर की भी और इस लेक्चर की भी आज या कल तक अपलोड कर दी जाएगी. सो थैंक यू सो मच. ओके, बाय. सी यू टुमारो इन द ऑफिस.
See you. Bye.
बाय.